In this video, we will talk about very important topic. This topic is mostly related to the non-abelian groups. So the topic is centralizer or normalizer of an element. So let us have a group G. This group G is preferably non-abelian because for an abelian group, these things are not important for us. And we are going to talk about centralizer or normalizer of an element of a group G. So we have to pick an element from G. Let A belongs to G. We are going to find the normalizer or centralizer for this A. So then the normalizer or centralizer of A is defined as C of A or N of A, because both things are the same for an element. So it is defined as the set of those elements of G which are permutable with A. G A is equal to AG. Those elements of G which commute with A. So the set of those elements of G is called centralizer or normalizer of that element in G. So in order to understand this topic, we have to do some examples. In order to understand this concept precisely, let's look an example for the non-abelian group. Since we know that D3 is a non-abelian group, let G is our D3. You know the elements of D3. These are the elements of D3. Its order is 6. Now let us have an element of D3 whose normalizer or centralizer is to be found. I will take these elements A, B and E. I will try to find the normalizer of these elements in G. You can find the normalizer for other elements as well. So I will find for them. So first solve its first part. We have to find the normalizer of A in G. So again, look at the definition. Definition says the normalizer of A in G consists of those elements of G which can be commuted to A. So we have to find those elements of G which are permutable with A. So what is G? G has 6 elements. We will check which element of G is can be commuted with A. So we will check them one by one. First look for E belongs to G. You know, we will check this E is can be commuted with A. You can see E times A is A. Also A times E is A. Both are same. This means E belongs to normalizer of A, right? So this element contains in the normalizer. Okay, now check the second one. For A belongs to G, you want to check that whether A commutes with this A or not. You can see that A times A is A square and A times A is A square. You can see that there is no difference. When we commute both A and A, we will get the same answer. This means A also belongs to normalizer of A. Now check this for A square. Now for A square belongs to G, we are going to check that A square is permutable with A or not. You can see that A times A square is A cube, but A cube is identity, right? What is the answer of A square times A? That is again A cube, which is again identity. Again both are same. This means A square is also lies in the normalizer of A. What is the next element of G? That is B. So check for B. For B belongs to G, you know A times B is not equal to B times A. Why? Because for the dihedral group Dn, we have a formula A to the n minus k times B is the same as B times A to the k. Got it? This is the general formula. In our case, we have D3. So in D3, we have to calculate this thing, AB. You know, AB can be written as A to the, we have to write A to the n minus k. In our case, n is 3. I will write 3. What will I subtract here? Because here we have AB, you have to take power of A 1. So I have to subtract 2 to get power 1. So now these two things are the same. But this formula says that it is equal to B times A to the k. Here k is 2, A square. So I will get AB is equal to BA square. So in this group, because I will write here, because AB is equal to BA square, therefore B is not in the normalizer. Therefore B is not in the normalizer of A. Similarly, you can check that AB is not in the normalizer of A. Similarly, you can check that A square B is not in the normalizer of. So the normalizer of A is A square, because you can see here A belongs to normalizer. You can see here A square belongs to normalizer. You can see here E belongs to normalizer. Where is E? Yeah, E belongs to the normalizer. So these three elements are in the normalizer of A. So we have done first part of this example. Now look at the second part. In the second part, we have to find the normalizer of B. We have to find the normalizer of B. So look how to do. What is G? G is A square B AB A square B in our case. So we will check which elements of G are permutable with B. So we will check one by one. For E belongs to G, we will check E is either permutable with B or not. You know, E times B is the same as B. Also, B times A is the same as B. Both answer are equal. So therefore, E belongs to the normalizer of B. Now check for this A belongs to G. For A belongs to G, we will check whether this A commute with B or not. You know, A times B again is equal to B times A square. Therefore, A times B is not equal to B times A. So A does not belong to normalizer. So if A is not in the normalizer, and we can similarly check that A square is not in the normalizer. Similarly, for A square belongs to G, you can check that A square times B is B times A. It should be B times A squared, but it is not the same. So this means that they are not permutable. Therefore, A square does not belong to normalizer of B. Now you will check that whether B belongs to normalizer of B, this element. Okay, we can check for B as well. For B belongs to G. So we will check that this B is permutable with B or not. You can check b times b is identity. Also b times b is identity. There is no difference when we permute them. So this means that b belongs to the normalizer because both answers are the same. For AB belongs to G, we have to check that whether it commutes with B or not. AB times B, we have to check this element commutes with B or not, because we are going to find the normalizer of B. We are going to find this thing. So we will check whether AB commutes with B or not. So here we have taken AB, here we have taken B. You can check A times B square, which is A, because B square is identity. Now look what happened when we change their positions. If B is here, AB is here. You can see AB. Put AB as it is, and AB is equal to B times A square. What is B square times A square? B square is identity times A square, which is A square. So what is the definition of left hand side? This is A. And what is the definition of answer of right hand side? That is A square. Both answer are not same. Therefore AB does not belong to normalizer of B. Similarly, you can check that A square B is not in the normalizer of B. Similarly, A B is not in the normalizer of B. You can check. So what is the normalizer of B? It has only two elements, E and B. You can see here this one and this one. So these are only two elements which are going to the normalizer of B. So normalizer of B contains only two elements, E and B.